Hello everyone. As you know me, in my last session so many times I have mentioned that if I have to learn functions, I should take help of graphs, figures. So in this session, we would try to draw only graphs. So this session is comparatively lighter than the previous ones because lot of heavy things you have already learned. So let us make it little more lighter. So I start with first y equal to ax plus b. Ax plus b is a linear polynomial. This you all know. Degree of x is 1, so it is called linear polynomial. Now, what are a and b? A and b actually can be anything. When I say anything, any real number. Positive, negative, we do not know. So my first case is a and b, both are positive. Then how does graph look? Now, I take x-axis, y-axis, and I try to draw the line. The best way to draw a line is the representation of y equal to x plus b. This you have already done in the previous classes. Now, whenever I have to draw a line, the best way is that you take 2 points, one on the x-axis and the other on the y-axis. This is best way to draw the graph of a line. That how do we take point on the x-axis? By substituting y equal to 0. And how do I take point on the y-axis? By substituting x equal to 0. So, you know basically the direction of the line. That whether line is in this direction or it is in this direction. This you will be able to see when you draw the line. And actually, the direction, what I am saying, that depends on a, right? So, here I have taken a greater than 0. Then line would look like this. And also, if I substitute x equal to 0, then y would be b. So, line passes through 0, comma b. I hope everybody understood that line y equal to ax plus b, when a and b both are greater than 0, would look like something like this. Now, we may change some conditions here and there. I take the second one. And I take now that b is 0 and a still greater than 0. If b is 0, then what will happen? That upper part, what I have shown in the previous graph, which I have shown as b, that would disappear. And hence, line would pass through origin because b is 0. And I have kept a still greater than 0. So basically, the direction of the line still remains same. Now, I try to take the third one. Again, I change slight condition. And the slight change is that I have made now a less than 0, but I still keep b equal to 0. And I realize that line still passes through origin like the second case. And the direction changes. Why direction changes? Because instead of a greater than 0, now I made a less than 0. I could have taken fourth case also, which I may not take here. And that case would have been that a less than 0 and b greater than 0. That would have been the combination of first and third that you try on your own and see how would be the graph. Let me move to the fourth one. And fourth one is, now I take a equal to 0 and b greater than 0. When I say b greater than 0, then line would meet y-axis above the x-axis, right? And if a is 0, then line becomes parallel to x-axis. And hence the picture. Line parallel to x-axis is the description for y equal to ax plus b, where a is equal to 0 and b greater than 0. Mind you, please, I tried to make some 4 various graphs out of taking different a and b. If you wish, you can write more, make more combinations and see how the graph looks. Every time it would be a line only, but maybe in different places, different directions. Let us move to next, and instead of now linear expression, I take a quadratic expression, ax square plus bx plus c. All you know in your previous class that quantity b square minus 4ac was very, very close to your heart, and that is called discriminant. So that I have written as triangle kind of symbol, that is called delta. So I write the discriminant as delta, which is b square minus 4ac. Now when we go for quadratic equations, that time you will understand more importance of delta. But right now I can tell you that heart of quadratic expression or quadratic equation lies in discriminant, and that is b square minus 4ac. And that is why I have already written there at the top. Let me try graph of y equal to ax square plus bx plus c. How does it look? I take case when a is greater than 0 and delta is greater than 0. Draw x-axis, y-axis. And the shape should take your attention, at least for this moment. Shape is opening upwards. And if I have said delta greater than 0, you all know that in your previous class you had said that roots for quadratic equation when delta is greater than 0 would lead to distinct and real roots. And that is why here I am showing, that is the connection, that graph would meet x-axis at two distinct points. Opening upwards is actually coming due to the fact that I have taken a greater than 0. That means a matters and delta matters whenever you are drawing graph of y equal to ax square plus bx plus c. So I try to take various cases. Means a greater than 0 and I change the sign of delta, or I change sign of a and I then keep delta greater than 0 and so on. Let us take one more. I take now a less than 0 and delta greater than 0. When a is less than 0, then graph opens downwards. Delta greater than 0 will tell you that graph still meets x-axis at two distinct points. Now again I change and I say I will take a greater than 0 and delta equal to 0. When I say delta equal to 0, you remember you had done that in case of delta equal to 0, that means discriminant equal to 0. Roots are real and equal. So graph meets the x-axis only at one point. And my last case is that a less than 0, delta equal to 0. A less than 0 will tell me that graph would be opening downwards. Delta equal to 0 will tell me that it would meet x-axis once only and the graph would look something like this. In these four cases, you may think that in one case I have shown the points of intersection of graph and x-axis only on the positive x-axis. Maybe in first and fourth also I have shown similar one. Even in second, you can see that point where graph meets the x-axis is on the positive x-axis. What I am trying to tell you here is that position where it meets x-axis is not important. It may meet totally on the left side of y-axis also. It may meet totally on the right side of y-axis also, or one point on the left and one point on the right side of y-axis also. Position where it meets is not important. Number of points at which the graph meets x-axis is important. That depends on delta. If delta is greater than 0, it will meet twice. If delta is equal to 0, it will meet once. If a is greater than 0, graph would open upwards. And if a is less than 0, then graph would open downwards. Now one more case is remaining where delta is less than 0. And when delta is less than 0, graph does not meet the axis at all. I hope you followed from the graph what I am saying. The graph does not meet the x-axis at all. It is fully above x-axis because a is greater than 0. If I take a less than 0, that would be my last case. And of course, still delta is less than 0. I draw x-axis, y-axis. I will find the curve totally below x-axis and opening downwards. Opening downwards because of a less than 0. Not meeting x-axis due to delta less than 0. One case before that, we have seen a greater than 0, graph opening upwards, but not meeting x-axis due to the fact delta less than 0. So this is about graph of y equal to ax square plus bx plus c. In this session, I restricted myself only to linear and quadratic polynomials. Please take different values of ABC, and if you wish, you can revise the topic again on your own. Please stay tuned till I come back with the next. Till then, bye. Thank you.